So it's an honor to be here, and I'm sure you all want to imagine what can be done with robots and what robots can do. But first, I'm actually asking you to use your imagination for something else. Like, imagine something totally different. How was life without robots? How was life a couple of thousand years ago? Like, a couple of thousand years ago, if you needed to get water, you took a bucket and you went down to the stream. Then you got water to like wash yourself or drink or something like that. And also, when you needed to get warmth or light or something like that, you went to the forest to get firewood and stuff like that. And also, when you needed to get information, you went to the market square to talk to people, to catch up on the latest gossip and so forth. And all these things have essentially been automated. You don't need to go anywhere to get water because it's running. It's everywhere where we need it. And you have information at your fingertips everywhere. And energy, of course, travels to you as well. But even today, when you need to get a Mars bar, you take a bucket and you go to the, not to the stream, but to 7-Eleven. So that has not been automated. And it might surprise you, but really the delivery of things or transport of matter is pretty much the last undisrupted industry in the world, where people still do this labor, people still carry things. You either go to the 7-Eleven yourself to pick up this Mars bar, or essentially via some sort of crowd sourcing platforms and so forth, you essentially pay somebody else to do that for you, to a delivery guy, wasting essentially their time to bring something to you. And this all actually can be automated. Imagine a world where movement of things, movement of matter, is actually automatic. That you click something and things just come to you. And they come to you 24/7 when you want it. It's convenient. You see the progress and everything related to automation, all the benefits come with it. For example, 20 years ago, if you wanted to book a flight ticket, you actually talk to a person like a travel agent to do the travel booking for you. And now that has been migrated to the internet. It's at your fingertips. People love it. You can do this. While in your underwear and so forth. People actually love interacting with automation, and I'm trying to create a future where people get the same level of automation with movement of things. Yeah, and you might think, this might come, long time, in the future, like, when we have flying cars. That's actually not true, Actually, of course, flying cars are being developed, but still, the wide-scale deployment of delivery robots happens actually way quicker. At Starship, we are doing daily deliveries in 10 cities around the world, today. And this is before flying cars are commonplace. This is before self-driving cars are commonplace, and so forth. And the cost of delivering things over on the ground with a robot like this is a lot lower than it is over the air, for example, drones and so forth. And cost matters a lot in this automation transport. We have done thousands of deliveries with these robots, with these partners and more partners. Not all of the logos actually fit onto the slide. And a lot of them are food delivery companies that we're offering transport services to. One of them, for example, is Zoom Pizza. So Zoom Pizza is a company that partially uses robots to make pizzas. So actually today, just a few miles from here, you can actually order pizza that is made by the robot and delivered by the robot to you today, so before self-driving cars. So this is happening today, and delivery robots are really practical and will get to wide-scale deployment much quicker than a lot of people think. I will talk a little bit on the history of Starship and how we came up creating Starship. But first, let's talk about the backgrounds of people and my own personal history, for example. So I was taught programming by my mother when I was 10 years old. Both of my parents were computer programmers. And I never thought that I would join a bank or something like that. I had always, since high school, I started creating products with my friends. And we started first doing computer games, and then other things. And then I met this gentleman called Janus Friis and also another gentleman called Niklas Zenström, and we created a number of startups together. Like, for example, Gaza, which was at some point responsible for about half of internet's traffic, and then Skype. And Starship is now our fourth startup together with Janus, and we are the co-founders. And I think I've been part of about 10 startups all in total. You don't know most of them because most of them have been very useful learning experiences as failures. Before founding Starship, I took part in a NASA robotics competition or challenge called Centennial Challenge Sample Return Robot. And this was a lot of fun. And I assembled a professional team of about 10 engineers to compete in that challenge. I was the leader of the team, and we didn't win the challenge, but I now had a robotics team. Before that, I was a software guy. Now I had a robotics team. Then me and Janus came to this idea of automating the transport of matter that can be done today and not when we have flying cars. And then we actually needed to build the robot. And this is Tallinn. This is my hometown. Actually, my window at the time is kind of visible, actually. It's left center there. It's almost on the photo there. And obviously, you need to build a robot first. Building a robot is hard. It takes a lot of time. It takes a lot more time than people think. People think that, okay, it's all solved right now, and all of the algorithms already exist. Let's just put them together. It's a lot harder in practice to do all of this and achieve a real, practical robot. So it starts, of course, with tinkering, with screws and things like that. And all of the startups that I've been part of, including Skype and so forth, they start in a small room where a couple of engineers are, tinkering things and so forth. So we did a lot of that in 2014 when the Starship was started. And initially we had 10 engineers. I essentially hired all of my NASA Centennial Challenge team to work on Starship. And we had a lot of mishaps, and a lot of things went wrong, and we learned and created better solutions. All of the hardware and software in Starship is created by this team in Estonia, so we haven't really used a lot of the open source stuff, which means we did a lot of learning, but in the end achieved a result which is really good. And this is there's a team photo. We hired more people. So next year we were already more people and more and so forth. And this is the robot here is our first prototype that we 3D printed, so that it actually had some sort of a designer-designed look and did not look like an industrial toy. And this was one thing that we realized from the very beginning, that we don't need to build a robot that looks like a robot. We actually need to build a robot that looks more like an appliance that has always been there, that people accept as part of their lives. Like, for example, people are actually used to robots in their homes all the time, but they don't call them robots. They call them dishwashers, for example. That's actually a robot, right? When people see really industrial or scary looking things that are doing, something like that, and do That's what people call a robot. We didn't actually want to create something that is called a robot. So we knew that we needed industrial design.
What's the name of the dog?
I don't actually know. The dog belongs to this girl on the left. You should ask her.
Okay.
We built more prototypes. It took quite a few prototypes to get it right. The first prototypes really did look like robots, but we knew that we needed them only for some experiments. And particularly, venerable workhorse is this first, 6-wheel things in the back there that had, the most wires and the most things. And I think this one lasted for like about half a year. We spent about half a year driving around in the streets of Tallinn with this one, doing experiments and gathering data and so forth. And this was a lot of fun, but you notice that it's built in this metallic construction kits, these universal kits that you can build anything with screws and metal bars and so forth. These are great. The unfortunate thing with these is that the screws actually come loose. And if you have hundreds of screws, at some point we actually couldn't drive more than like half a mile before we had to repair it again and again. So it's paid to actually transition to more industrial production prototypes that actually did not have too many screws. So each of these things has a backstory here, of course. This blue thing was a test prototype that essentially had the same camera placement as the real thing, but was a lot cheaper to produce than this 3D printed or other nice looking things. There was a lot of things that we went through. We started experimenting with how things look, and but we did want to hide how things look because we were a stealth startup, and we didn't really want to show how our robots look. But we did want to do some experiments, going in the field. So we actually used this plastic bag to cover the robot and still be able to drive. We did holes in this plastic to be able to gather data from cameras and so forth. So that's how those experiments worked. But now let's show how the robot drives a little bit. So it can drive around. It has 6-wheel drive. It goes with pedestrian speed. And it's designed to be a sidewalk robot. So it doesn't enter buildings. It doesn't drive on the road. It's not like a self-driving car. But it has tons of sensors and cameras in front here. And it's normally locked so that people can't steal stuff from it. But when it gets to your location, it stays on the sidewalk, and you get a message on your phone. Then the light turns green here. You can open the robot, take out your stuff, close it, and send the robot away. So that's broadly how that works. The control model for the robot is hybrid control. So it's not actually fully autonomous. We actually don't have the intention to build a robot that is going by itself all the time. It's actually helped from time to time by human operators who sit in control centers, like in Washington, D.C., for example. And these people, these operators, they get a 360 view around the robot, with the cameras and so forth, and they can help robot with decisions. Like, for example, is this obstacle here something that the robot should, turn back for, or can we just drive over the obstacle? Things like that. And it can, of course, react to pedestrians and go around pedestrians and so forth. There's tons of intelligence in there, but in general, still, it's a lot simpler than a self-driving car. Although certainly, it has taken a lot of time, a lot of effort to build this to perfection. There are a couple of limitations with robots like that. Like one is, for example, that since this is a pedestrian speed device, it's naturally limited in range. Like this is not intended to transport something from one city to another or across the city. But there are solutions to that as well. Okay. So what you see on this picture here is a range extender for robots. So it's called a van, and it's built in cooperation with Mercedes-Benz vans. So this has a tight integration between the vans and the robots. So the van functions as a mothership for robots. Robots automatically onboard the van, and the van drives them to a neighborhood and dispatches them from one location. They go and do their deliveries in parallel and return to the same van or to a different van. So there's this set of automated ramps and things like that really extend the range of the useful range of robots. And this is useful in package delivery and so forth. Now, what have we learned in these trials that we have done and this experience that we have done? People really love robots. What can you do? Sometimes, kids feed robots bananas. And this social acceptance and the way how people react to the robot and how they behave around the robot and how the robot should behave around people, this is super important in this business, because this robot is driving in a pedestrian environment. And obviously it must respect pedestrians, it must respect their rights and their space. And all of the miles that we have driven, which is lots, have been useful in collecting information on how the robot should behave. We have a data team, which is 8 people, which is just focused on the data infrastructure and gathering data and annotating data. So all of the social interactions, if anyone had a problem with the robot, if the robot had a problem, climbing up a curve or something like that, or there was a safety issue, all of these issues, even the slightest such happenings, are annotated and analyzed, and that's actually primarily a big data exercise, because a lot of things are happening on the sidewalk, and we are learning from the data all the time. The main thing we actually have learned that actually, average, like per mile, very little actually happens. And it might surprise you, but most people actually ignore the robot. And initially we thought that if you put a robot like that on a sidewalk, like what will actually happen? People will be afraid of it maybe. We wanted to, of course, to design it to be friendly and so forth, but still, it's a robot. People would think maybe it's dangerous. Maybe people would call the police. Surely they will pay a lot of attention to the robot. It doesn't actually happen so much. Even people who are not familiar with the robot, they just walk past the robot. And that's amazing, and that's actually something that people, sitting in an office or in an audience like that, in a closed room, people actually don't think this will happen. People think usually that this robot will actually cause a lot of attention on the sidewalk. Like people, everybody would stop and take a picture and post to Facebook. That actually doesn't happen so much.
If I could just interrupt. So those of you who remember Segway, so Dean Kamen's company, when did they come out? Was it 2000, 2002, something like that? Kleiner Perkins portfolio company. Never got traction. They were supposed to be, the vision was to have Segways driving on all the sidewalks of American, European, global cities. Never happened, in part because, one, regulatory, but two, these social acceptance issues. So the challenge, so next slide.
Yeah.
Challenge for Starship is how to avoid the mistakes that that Segway made.
Right. You also mentioned the regulatory environment. That's of course important, because we are not actually in the business of creating something illegal. We want actually to create something that people accept and want to have in their cities. And traffic laws around the world are not often built with robots in mind. So actually people have had to change the laws sometimes, or give us specific permissions to operate robots, in those 10 cities and more. But actually, politicians and regulators are racing to change their laws and to make sure that robots are legal in their sidewalks. So in the US, there's a number of states that have changed their statewide laws. in California, here in the Bay Area, there's a number of cities that have specifically allowed sidewalk robots on their sidewalk, like Foster City, Sunnyvale, Palo Alto, you name it. There's San Jose. There's a lot of cities, like 10 cities around here that have made the necessary changes. And the country of Estonia, where our R&D is, became the first country to change a nationwide law to make sure that robots are allowed on the sidewalks. So this regulatory change is happening, and while some people could have thought that this could actually be an obstacle, then it actually hasn't been an obstacle. Of course, there are some cities and some places that do not want those robots, at least not in large numbers, in their sidewalks. San Francisco has recently moved to regulate sidewalk robots in a way that does not really allow wide-scale deployment. But for every such move, there's actually 10 cities like Foster City and San Carlos and San Jose and so forth that are much more welcoming to change the regulations to make sure that robots are legal. So further on, I discussed about how we built the robot and how we did the engineering work to make sure that robots are autonomous and so forth. But there's a long way from a prototype to an actual practical scalable service. And this usually takes a lot of time. Some people don't really appreciate that. Some people think that once you build a prototype, oh, it's a simple thing. Next month you will be like in 100 cities or something like that. That's actually a totally different thing. To scale, you actually need a practically operatable service. That includes things like maintenance manuals, standard operating procedures. You need to invest in urban planning. How do you charge the batteries? All of these things need to be sorted out, and this is something that we have done over the last 2 years. We are still in progress with some of these things, so we're not fully ready yet, but these things will hit your sidewalks sooner than you think. And this is being helped by a bunch of people, including a couple of investors. So we have been lucky to enjoy the cooperation of these people, and have had more than 20 million in funding. Of course, me and my co-founder Janus Fries, we have put in also we put in the initial seed money, and this will not be the last robot we are building, and this will not be the last model that we are building. So we will be able to automate the whole of urban transport pretty soon. Thank you.
Thank you. So we'll take a couple questions now for Ahti, and then we'll go into our panel mode. Yes, sir.
Yeah, I was wondering if your goal is to find your software that someday be able to sell that as intellectual property to other companies who want to have robots so that it's 100% autonomous.
To license our software to other companies? That's not the primary business plan right now, but in the future, I'm not ruling out anything, not even world domination.
Yes.
So in addition to pen and paper legislation work, there's you have to cross a sidewalk, which requires a mechanical push. So that most likely should be a interface between the street light and the robot. So is that being kept in mind?
Yeah, so we haven't actually built that, even though some cities are open to integrate their traffic light control systems to our robots. But by and large, we have actually found that this is not really as big a problem as some people think. We have mapped all of the sidewalks, all of the traffic lights in the cities where we operate, and we know which are button operated, which are not button operated. We can take an alternative route, and also in these button-operated traffic lights. These are usually in busier areas. In busier areas, they're actually pedestrians crossing. So if pedestrians are crossing, somebody's pushing the button. So all of these practical details, of course, it's a great question. There's about 50 other questions like that. we have worked through all of those 50 questions that need to be answered to get this to a practical service.
Yes, Elif.
We've seen a lot of videos on the internet of people walking around and looking at the phone, tripping over things. How many people have tripped over your roadblocks so far? And are they legal or issues in terms of liability?
Yeah, they're legal, and of course we have insurance as well. But I don't think anyone has tripped over our robot. Of course, it's hard to really judge. If I'm doing like that, is it really like tripping over the robot? A lot of things happen on the sidewalk, but certainly we haven't caused a real injury to anyone.